Okay, good day everyone. So this time we'll be discussing to you about some topics in Mathematics 10. This is all about finding the zeros of polynomial functions, and also I include problems with solutions on circles. Okay, so first we'll have the an example of finding the zeros of the polynomial. So actually in finding the zeros of polynomials, there are actually a lot of concepts that we can actually apply, in getting the zeros. First and foremost is if the given polynomials has the what common monomial factor, so we can use it, just like for example in this first one example, we have p of x is equal to x cubed plus 3x squared plus 2x. As what we observe, each of the term has an x term, or has an x in each term as what we observe. So therefore, we can remove the common monomial factor, or we can factor out using the concept of removing, its common monomial. So we have here the solution first. We let p of x be equal to 0. So we have here x cubed plus 3x squared plus 2x is equal to 0. And after that, we can now factor out x, because we know that x is common to each of these terms, no? So we have x now times the quantity of x squared plus 3x plus 2 is equal to 0. So we just factor out x. Then we know that x squared plus 3x plus 2 is also factorable using two binomial factors. So we have here, that's why it is being simplified as x plus 1 times x plus 2. But actually, that is just corresponds to x squared plus 3x plus 2. Then at this time now, we can equate each of these quantities by 0. So we can have the first factor, which is x. So x now be equal to 0. So that will be our first 0 of this function p of x. Second, we have here the binomial x plus 1 is equal to 0. So we have here x now is equal to negative 1. So we transpose 1 to the other side, so become negative. Then the second binomial factor of x squared plus 3x plus 2, we have x plus 2. Okay? So we will equate x plus 2 to 0. So we can now find the value of x, which is negative 2. So therefore, okay, the zeros of this function p of x is equal to x cubed plus 3x squared plus 2x are 0. Then we also have negative 1 and negative 2. Okay, let us have an example 2. So we are asked to find the zeros of this given example. P of x is equal to x cubed minus 3x squared minus 4x plus 12. In this type of cubic function, okay, so we cannot actually use the concept as what we use in, or as what we do in the first example. We use the removing common monomial factor. Okay, but at this time, okay, we can actually apply the concept for which we can make use of trial and error by using the factors of 12. Okay, so we have here, first we have let p of x be equal to 0. Then we have x cubed minus 3x squared minus 4x plus 12 equals 0. Then we can now use the factors of 12, which are, so these are the factors actually of 12: plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. So how do we use these factors? So we can actually make use of these factors by substituting this value to the variable of p of x. Then at that time, when p of x become, or equivalent to 0, or become 0, so therefore it means that that value that we use for as replacement of x, so it means that that will be one of the zeros of the function. So we have here, we try to use x is equal to 2. So as we use the original function p of x is equal to x cubed minus 3x squared minus 4x plus 12, we found out that from that we have 2 cubed minus 3 times the quantity of 2 to the raised to the power of 2 minus 4 times 2 plus 12. When we are going to simplify, that will become 2 to the power of 3, which is 8. Then 3 times 2 to the power of 2, that become 12. Then we have negative 4 times 2 is negative 8 plus 12. Then if we're going to simplify, that is actually equal to 0. So therefore, 2 is one of the those zeros of the P of x. Okay, so at this time now we can make use of the synthetic division. So we know that 2 is one of those factors of x cubed, or zeros of x cubed minus 3x squared minus 4x plus 12. So this will be the number now that we can place inside the box. Okay, so we have here, so we will put positive 2 in the box because we will be using now the synthetic division. Then we will also list down the numerical coefficient of these polynomial functions. We have the first numerical coefficient of x cubed, 1. Then we have for x squared, we have negative 3. And for x is we have negative 4. And for the last one is the constant term, which is 12. Then, so we can now have or bring down 1. Okay. Then multiply it, the number inside the box, which is 2. So 1 times 2 is 2. Okay, so we have 2, or negative 3 plus 2 become negative 1. Then negative 1 plus 2, negative 1 times 2 is negative 2. Then negative 2 plus negative 4 is negative 6. Okay, then we will multiply it to positive 2 from the box, so we have negative 12. Then when we simplify 12 and negative 2, negative 12, so become 0. So it means that 2 is really one of the zeros of the function p of x. Then we will have now to rewrite from this one, the result will be corresponds to the quadratic function. Kay cubic function man ang previous, so mahimo siya quadratic function. So become, the first term we have x squared, the second we have negative x here. Third, we have negative 6 as the constant term of this quadratic function. So as what we observed, this is actually factorable, x squared minus x minus 6. So we can have now two binomial factors. These are x plus 2 and x minus 3. So if we're going to multiply x plus 2 and x minus 3, it will go back to its original form, which is x squared minus x minus 6. Okay, then after that, we can now equate x plus 2 and x minus 3 by 0. So x plus 2 is equal to 0. Transpose now to the other side, the positive 2 become negative 2. X minus 3 now, when we transpose negative 3 to the other side, become positive 3. Okay? So therefore, the zeros of p of x are negative 2, positive 2, and positive 3. Okay? So let us have here the problems on circles. Okay, we are now going to find the measure of the indicated angle in each figure of the circle. So we have two figures in here. First, we have here two chords and we have the radii. Okay, so we have chord AC and chord AT. From problem number 1, measure of angle A is what we're going to find out. No? We know that angle COT is the central angle that is correspond to which has a measure of 127 degrees, and it is also congruent to its intercepted arc, which is arc CT. So they are actually equal in measure. So we have 127 degrees. We know that angle A is actually what we call as the inscribed angle. So therefore, its measure is equal to one half to its intercepted arc. So the intercepted arc of angle A is the small arc, no, which, or the far arc, which is arc CT, no, that has a measure of 127 degrees. So because x is equal to 84 degrees, then therefore, okay, 84 degrees man siya, so that is referring to the arc EN or angle EUN, no, not angle EUN. Of course, that is actually the same angle EUN, no? Then all we have to do is we can now identify the two inscribed angle, which are angle A and angle M. So we will now be using that one. Okay, for that one, we know that we have x is 84 degrees. We know that measure also of angle A is equal to measure of angle M. Okay? that is 1/2 of 84 degrees, because that is corresponds to its measure of the intercepted arc of these angles. So we have 84 degrees divided by 2 become 42 degrees. So this is the measure of, therefore that is actually the measure of angle A and angle M, 42 degrees. Okay, so we have here the next example. I guess this is the last one. We have here circle S has a center at 1 and 7 and passes through the point -5 and -1. So we are asked to find the standard equation of the circle S. So we know that this circle has a center at h and k. So therefore it is in the form of x minus h to the power of 2 plus y minus k to the power of 2 is equal to r squared. So the center is at point h and k. And in the problem, there is actually a given measurement of the center, which is at 1 and 7. So therefore, h now is equal to 1 and k is equal to 7. So for r, so we still have to find out the measure of r squared using these 2 points, 1 and 7 and -5 and -1. So we know that h is equal to 1, then k is equal to 7. So the standard equation of the circle centered at h and k, so we have here, so this is actually our partial equation. Kx minus 1 to the power of 2 plus y minus 7 to the power of 2 is equal to r squared. Then we can now identify the quantity that is equivalent to r squared by using the distance formula. We have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so using that these 2 points, 1 and 7 and -5 and -1, we can actually interchange x1 and x2, no? Between these 2 points, 1 and 7 and -5 and -1. So the first number in this ordered pair will be referring to x value. And the second will be for the y value, which is 7 and -1. Then therefore r squared is equal to -5. We let as x sub 2 equal to -5, and our x sub 1 is -1 or 1. Okay, then squared plus -1 minus 7 squared. So when we simplify, that is actually equivalent to -6 to the power of 2 plus -8 to the power of 2. Then squaring from the right hand side, so we have 36 plus 64, then that is actually equivalent to 100. So therefore, the standard equation of the circle centered at 1 and 7, then passes through the point -5 and -1. So we have here the quantity of x minus 1 squared plus the quantity of 1 minus 7 squared is equal to 100. So I hope that this will help you, particularly in answering your activity similar to this one.